Okay, let's get started. It's somehow already December 2025. This is going to be TRiRODS. I'm going to introduce myself. So, hi, I'm Terrell. I'm in charge of the iRODS Consortium. I think I did the last one 2 years ago when I looked back at the list. So, 2 years is enough time. We'll do another TRiRODS. Today, we're going to talk about the effort we've recently put into identifying some easy metrics around iROD, just some visibility. This data has always been in there, but you had to know things. So we're going to try and string together some open source tools and show you how you can see even more. You have to click on the right window. There we go. So like I said, this will be maybe 20 slides, not too long. I'm going to talk about time series in general, show the dashboard that we've kind of produced here, how we did it with the three tools that are in the title. And then in a bonus surprise, being able to capture transfer information, and then a little bit about the future. So, iRODS has always been a programmable virtual file system, right? It provides a space where people can write rules to take action on data based on stuff that's in the system, stuff that's outside the system, um, and that can happen on disparate storage systems across different technologies, and that can be here or there, or both at the same time, right? So this is a pretty powerful system. It also has a bunch of metadata involved, and that is both system metadata as well as, things like timestamps and sizes and stuff like that, as well as arbitrary user and administrator defined metadata that can be put on, data objects, collections, storage, things like that. And all of this knowledge, all of this capacity, except for the bytes on disk or tape or whatever, that all lives in a relational database. And so because of that, all this information is available via SQL. So, so far, so good. However, iRODS does not know what happened yesterday. It is only a view into right now. iRODS uh, has a truth, it has a state, it lives in the database, but it does not have any historical information about what used to be. And so if you want to know what happened before, well, then you would have had to have asked then and had to have saved it for later. And so we're going to not teach iRODS how to store this information. We're going to provide a couple tools that do that. So the best practice that we've, you know, this is how this works. You regularly query something for metrics, you write them down, and then later you come back and draw pictures, right? This is time series. And so these three tools are all open source. I think they've all got different licenses, or at least they don't all have the same license, but they are all open source. And so we strung them together to produce some pretty pictures. This is a graph that we now get for free out of the box in the iRODS demo. And I wonder if I can zoom in a little bit. Can I do that? Look at that. So this is showing some transfer information. So don't look at that. That's a few slides from now. This is total user information, number of groups. This particular install has, what is that, 23 million collections, 270 million objects, 516 million replicas. This is a 13.5 petabyte installation. The number of good replicas, the number of stale replicas, 109. Intermediate and locked are still at 0 in this case. Most of them have checksums. In fact, the vast majority, only 131 replicas don't have a checksum. So for the policy for this installation is that everything should have a checksum. They've got 131 strays running around. So, there could be some kind of script or automation to kind of identify those things and attack them, make sure they're kind of fall into line. What's hilarious is that if you have 13 petabytes in your system, you might have 14 terabytes in the trash. Um, I think this was enlightening when they first saw this. That's good. This is information about the different resources. This is bytes per resource. So they've got a bunch of different resources with, 170, 180 terabytes in a bunch of them. Um, and then number of replicas per resource information. All this is in the database. It's just a matter of asking it via SQL. Down here at the bottom, We've got some time series of bytes per owner, collections per owner, so you can see things as they change. This was only run over the course of a weekend, every, what is this, couple hours. So there's not so it's not a very pretty line graph, but all the stuff is in here and available at any time. And so this is exciting because now we get it for free, or at least for free in the demo. Probably for production use, you should probably know what you're doing and wire these things up a little bit better. But for some out of the box goodness, it's pretty, it's good. So this is a graph of the different containers available in the iRODS demo. If you go to the iRODS demo and you just say Docker compose up, you will get whatever number of that circles is, 15 containers running. The three on the right over here are the ones that we're going to talk about. And this is Grafana, Prometheus, and SQL Exporter. You'll notice that they are not talking to the provider. They are talking directly to the catalog. And this means that it's out of band of any traffic that you actually are having in your system. So if by running the metrics, you're not going to be affecting the metrics, so to speak, except for maybe the load on the database itself, if you're measuring that. So to go through the three tools, the first one is SQL Exporter. Here's the URL. You can go find it. This is mostly text from the READMEs of these particular projects. So this is a single process whose job it is to read a configuration file, and those define SQL queries, also known as metrics, and it prepares them for use by a Prometheus system. So if your system doesn't already produce metrics, this is a nice, easy way to produce metrics from a database system. We are happen to use Postgres, but SQL Exporter can actually talk to a lot of different things. These are strictly configuration files. There's one configuration file. The other interesting here is that you can put things into collectors. Collectors are a group of metrics, and then per collector, you can set a interval time. And that's important because if Prometheus is coming along every minute, but it turns out that the SQL that you want to run takes 5 minutes to generate the answer, you don't want to hit the database every 10, 20, 30 seconds for something that takes 5 minutes. So SQL Exporter will actually produce a cached version of the answer until that interval time has passed. So you can separate your SQL queries or your metrics by how fast or slow it takes them to run, depending on how often you want to run them. Otherwise, you'll just get cached information, which is fine. So it provides that buffer. This is what they look like in terms of the YAML file, which is the single configuration. Basically, you give it a name, some help text. In this case, all the values are very simple. It's just a simple count. But this is the thing these are the three that are producing those first three on the screen that were the number of users, the number of number of groups. And it's just direct SQL into, in this case, the iRODS database. So nothing too tricky here. Happy to take questions and comments at the end or in the middle if you want. Prometheus, the second tool in the chain, is an open source monitoring system, and it basically scrapes systems that are providing metrics, in this case being provided by SQL Exporter, and it collects those metrics from that target at a given interval and then basically saves them. We are not doing some of the stuff at the end of the sentence, displaying the results, trigger alerts. We're not doing any of that with this particular demo, but that stuff is available. The configuration for Prometheus is really about the targets. So in this case, there's a scrape interval at the top, 15 seconds. I don't know if that's legitimate for production. It's probably overkill. Depends on what you're measuring. In this case, there's two jobs that Prometheus is actually watching, two targets. One is itself. So hilariously, Prometheus produces metrics on itself. And so Prometheus can scrape itself and then keep those internal metrics, but using its own system. So that's pretty funny. And the second one, more interesting here, is the one called iRODS. The job name doesn't really matter. It's just in this case, there's only two things. And then the target is, you'll notice, port 9399 coming out of the SQL exporter binary or container, which itself was pointed at the iRODS database or the catalog. So Prometheus is just scraping a place and then making it available and keeping the results. Grafana is the third circle. It is a monitoring tool and graphing system. So um, it's very good at time series databases, and it allows you to pull metrics out of Prometheus and draw them. So again, we're not doing anything with alerts right now, but that could be figured out in the future. Grafana's configuration is actually for this setup is a couple files. One of them is a JSON file that defines the dashboard itself, and that is very, very long and doesn't fit on a screen. But you can imagine that it's just JSON, basically describing the UI configuration tools and things. The more important one here is the fact that the data source for Grafana is just the Prometheus endpoint. So we've got these things pointing at each other. I think the last one there, editable true, just means that if you set this up, then you can edit it in the Grafana interface and move it around. But this is the minimum thing that got us off the ground. Here's the same picture again, just to show you that it still works. Nothing happened. Screenshot didn't move. Just give you a chance to look at it. Separate from this, um, we've heard from a number of, well, our users. Of course, users of iRODS are largely administrators for other people's users. So, or their own users. And we're realizing that a lot of these installations are now being asked in the current climate to get paid for their efforts. A lot of universities and installations were uh, basically giving away storage to whoever showed up because that was their mandate. They weren't asked to charge for it, and now they're being asked to keep track of things. So with quotas and chargeback models, this is, again, it's already in the database. Might as well be able to pull it out. So, like I said before, iRODS has never captured historical data, so we never actually could answer this particular question before. How much data has user X moved in or out in the last month, right? We couldn't answer that because iRODS didn't have a historical view on things. So the goal here was to capture some of that information and write it down. This is a demonstration using the iRODS rule language. Again, this is a proof of concept. It does work. So far, no known bugs. It could easily be hardened and optimized into C++, right? Pulled into the server itself. And it will provide administrators ability to see what's going on and be able to charge their users in a service-oriented environment, maybe even justify their continued existence. So here is some iRODS rule language. If you blur your eyes just right, you'll see there's just a function at the top called add transfer. We'll talk about that in a second. The next 5 functions are all PEPs, policy enforcement points. If you look just right, you can see that they are about read, write, get, and put. Not in that order. Write, read, put, get. And the last one is the bulk put operation or API. And that one has to do a little loop to get the totals because there's actually up to 50 files have been glommed into that bulk put. So it walks that array and adds up the totals and then runs add transfer at the last step. So you'll notice that it's a username, a directionality, and a total bytes. And those are the inputs into the add transfer function. That is, you know, basically building a query, building a set of arguments, and then pushing them to a shell script. I don't think I have the shell script here, but the idea is that it puts it into the database. Okay, here's the insert that shell script is running. So the shell script pulls in 3 values, and those 3 values correspond with the table that's being inserted to. So for this demo, I added a table to the iRODS database. And this is what we would consider to be pulled into, a production version if we wanted to do this. Happy to get feedback on this. And it's just tracking total transfers for each user in and out. The last part here at the bottom of the screen, you can see for this particular user, there's a number of bytes, easy enough. This X bytes is considered like a rollover once this number gets too big. That can be done out of band later in a passive transactional way, so we don't have to worry about it for now. We're just using zeros up here. So it's inserting it if it's not there. If it is already there, then it does an addition. So the next things really are that we're looking for community feedback on whether this is any good. The screenshot came from Cyverse in Arizona. That's their 14 petabyte installation. They've already kind of running it. They're feeling it out and seeing what works. But I'm sure that these queries that I defined are not perfect. Not bad, but maybe too heavyweight or not optimized. There might be some indexing that we could add to make things faster. This is only for Postgres right now. Uh, and obviously, more dashboard knowledge. This is a cursory attempt at putting it in front of people. We're also interested in learning about scraping intervals, which queries are fast and slow on different sizes of installation. Um, right now, this is not something that thinks about multiple zones or even multiple servers. But if the policies are built in, we can make it so that they can all talk to the database. Or maybe there's something where each server, no matter where you connect, has its own little queue in memory, and then it aggregates for you and does it in the background. Some trade-offs around what happens if the power gets pulled on the machine. Is it critical that you have all that data, or if some of the stuff that's in flight kind of got lost, and probably over the course of enough time, it doesn't really matter if you lose a few bytes of the transfer total, but we'd probably want to build a way for that to be a knob for the administrator if it matters. And then of course, maybe absorb this into the server itself if this is good. Last slide is a pitch to come to Barcelona next June and July. We're very excited about this. It's a little bit early. It's only December, but we're tickled that we got this save the date done. So come join us. And then otherwise, thank you and happy to take questions. Are there any questions? I'll submit to show you.
So the dashboard you showed, that was from the iRODS sample repository? Is it already there?
The one in the slides, this is from Cyverse. This is
Okay.
their production Prometheus that they dropped our little dashboard JSON in there, and they were able to see, um, so you can see that this person transferred in an extra 30 gigs between 4 and 6 p.m. or 4 and 6 in the morning, whatever time zone we're looking at. But this is also the IPC admin account, so it could be some kind of script or something. But yes, this translates into the ability to see transfers in and out.
Cool.
I do have a live version over here. It's running in the demo, and so it's got only 14 collections and 2 gigs, and so I can run if I said 40 megabytes, and we wait a few seconds. It's got refresh on 10 seconds right now. I think it'll take 15 or 20 for the numbers to line up. But we should see, what should we see? Total objects should go up to 4, I think, in a few seconds. There it is.
Yay!
Live demos.
It worked.
Yeah, the red and green is throwing me off. It's Christmas. That's what it is. I'll go with Christmas. Mostly, I think it's just whatever the default. Oh, that's a big number, and then it turns a different color. What would you like to see out of this system? Does this align with what you would expect? Do you already know about these tools, or is this new? I want to ask you questions.
Well, you did give me an idea about how we could use the concept of your chargebacks to also try to track anomalous users,
Hmm.
which is really a big thing here where we're at. Like, you don't
What
want
what is
somebody.
what is the definition of an anomalous user?
If all of a sudden a specific user attempts to access files they're not allowed to see in
Oh,
great
okay.
bulk, or pending a restructuring, decides they want to download a lot of files that
Yeah.
they may not be allowed to take with them.
Yeah, yeah.
So something like that,
So
where,
that would have to be um
and that was kind of why I've been doing the audit module stuff too,
that's right.
that I've
That's
got
right.
working, and I'm pumping just raw like gets into Azure Analytics, but I
Hmm.
have yet to do any aggregation or analysis on it. And I was thinking that the chargeback might be a good way to shortcut that effort.
Right. If it's just transfers in and out, you can just watch those you know
Yeah.
oh,
Like if user A all of a sudden is grabbing,
right.
more megabytes than they normally would, or gigabytes than they normally would,
Hmm.
and
Hmm.
it's not
And
typical
that's
behavior.
probably a function of the dashboarding itself to be able to say, show me greater than anything over 1% out of deviation in the last week or something. I think there's probably functions that you can do when you build these little element things. These are all very
Yeah.
simple, just counters,
Yeah.
but there's lots of things that you can do with, ranges and percentage change and that kind of stuff.
Yeah. I haven't actually gotten to, you know, doing the analytics part of it to see what
Right,
I can pull
right.
out of it.
But I imagine that even with just this number and a bunch of timestamps, you can probably see some of what you're asking for.
Yeah.
And that would be very cool. I mean, I would love to have a little box here that shows, most active users in the last week or most active,
Yeah.
largest percentage change in the last, something like that. So those are the kind of things
Yeah.
that I would love to hear about new boxes that I can add to this for free because I think people will like that.
Or when your stale files get up above 6,000,
Well, that's right. That would just be a threshold on this little guy here, right here.
Yeah.
Excellent.
Yeah.
Anybody else?
Thanks, Terrell.
Yeah,
And I got to
no problem. Thank you.
I have to bounce as well. Thank you.
Okay. Yep. Excellent. Well, I will thank you all and turn off the recording. Thanks a lot.